in my absence, I would like you to fill in the note today that I have that's connected to lesson number, is it 10? Lesson number 11, okay? So what hopefully you've already done your warm up here. So you've done this part, now you're watching the video, you can work on some homework questions. Fairly long video, but hopefully you have some time to work on the homework questions. And if not, try taking them home, okay? Try to have them finished for tomorrow. And then do an exit card before you leave. Excuse me. I am just in a meeting in the library, so if in need, you can reach me. Okay, and you do need to have Desmos available to you, so get a if you don't have an iPad or something already, you should have that good to go. And remember that if you can't get the app on your phone or whatever, you can get it on the internet. Just hit in, Desmos here. Usually it just comes right up. It's left and came back to it. Okay. All right. So let's get started. Here's the purpose of today. We're looking at parallel and perpendicular lines, and today's lesson ends with one of what I call the grand poobah questions of the course, some of the hardest things I can ask you. I don't think the topic in general is that hard, but just these really hard, there are a hard question, and there's one I'm going to give you today that I call the grand poobah, and then tomorrow I'll show you the mother of all questions. It's really hard tomorrow or the next day. Okay, anyway, so that's what we're doing, and I want to remind you and Mr. Gates that if I start to go too fast, like I will go too fast, I sort of intend to keep the video short. The goal is that you just pause, right? Pause the tape, and then you can catch up on the writing, and then you hit play again when you're ready to go to the next page. So I'm going to keep moving fast. You, of course, can stop when you need to. So when we talk about parallel lines and perpendicular lines, parallel lines look like this. I'm sure you would have studied them in some way in fashion before, and usually they have like little hash marks that say, assign to you that those are parallel, besides the fact that they look parallel, is that they have little doohickeys on them that say that they are parallel. And if they have a double hash mark or just one, doesn't matter, but it's just something that says those are parallel. They're never going to cross, ever. That's the idea with a parallel line. A perpendicular line, you may not have studied this before, but it means they meet at a 90-degree angle. Okay? And the kind of thing that we're studying then today is the idea that these lines have equations, right? Both of these lines have equations, and those equations, you should be able to, if you know the equation of one, be able to predict the equation of the other. There's things that are similar, and I think right here, for example, same slope. Okay, so you think of an equation of a line, then you know what would be the same and what might or could be different. Same thing here. These aren't the same slope, so you've got to figure out that connection. So yeah, parallel lines have the same slope. Perpendicular lines have slopes that are what we call negative reciprocals. And I'll show you what I mean. You can take down these before, you might want to pause and write down these graphs. Just notice, please, that each of these red lines has a slope of 1 up, 2 over. Okay? You should have a slope of 1 up, 2 over. So once you have the lines down, then we can add, I'm going to add a parallel line to this. And again, you can ask yourself what's the same and what's different. For a line to be parallel, for me it's easy, all I got to do is copy and paste. Because a parallel line is going to look exactly the same. It just might be up here. So what's the same is the slope, and what's different is the y-intercept. Okay, so parallel lines have the same m, but different b's, and that's what you should see right here. Perpendicular lines are different, and I wanted to take a look at Desmos for that. So I'm going to slide over to Desmos, and let's look at first let's look at parallel lines just because we can. Say I draw a line that says 2x plus 4, okay? And now I want to add a line, and what would be a parallel line? And what would an equation I could enter for a parallel line be? And the things that are the same is the slope, and what's different is the y-intercept. So I could say y equals 2x plus 1. And if you look at those two lines, they are parallel to each other. So any two, again, I could choose different slopes if I wanted to. I could change my 2 to a 6. As long as I change that to a 6, those lines are still parallel. They'll never cross. And you could play with that, obviously. We could do fraction slopes. You could go 1 over 2, 1 divide by 2. Hit the divide button, 2. And then this one would have to change to 1 divided by 2. So if you want lines to be parallel, you just make sure that the m part is the same, and they'll always be parallel. And so that's a very, very typical question, is name an equation of a line that would be parallel to y equals 1/2 x plus 4. And I said 1 in this case, but I could change this number to anything. 2, still parallel, right? I could change this number to 3, still parallel. I could change it to 4.5, still parallel. So changing the b part of the equation doesn't change the fact that it's parallel. It just changes where it, how far apart they are. Okay, so the m part, the slope part, has to be the same for parallel lines, but the y-intercept different. Now, perpendicular lines are a different story. If I started with this line right here and I wanted to draw a perpendicular, I do know the answer, but if I wanted to try to figure out something you can do in Desmos is I could write mx plus, let's just say 1, okay? And so see, I just wrote y equals m, because I'm going to try to figure out what should the slope be. And you could start to ask yourself that question, what should the slope be for it to be perpendicular? One thing I'll tell you is that it should be negative, because it's got to kind of go like this. It's going to look like something like that, right? So what you do in Desmos you can do is you can write y equals m, so you don't put a number in, and then it says add a slider, and then you can just play with that. So see how, like I was going to try parallel, try to get it to 0.5. That would give me a parallel slope, right? Because 0.5 is the same as 1/2. But I want to find something that's perpendicular now. So I'm just going to play with this, rotate it till it starts, that's looking closer to perpendicular, right? Trying to look at, so what I'm looking at right now is right here, and I want to stop when I have what I think is 90 degrees. So you can play with it till it looks like it's a 90, it crosses at a 90-degree angle. That's looking closer, 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 and that would be a 90-degree angle. Okay, so for this line to be perpendicular, this one's 1/2, this one's -2. Maybe we could try to find a relationship there. Let's try some more numbers. Let's try 1 over 3, 1/3. And to get perpendicular, where would it have to be? So you can keep playing with it. That looks pretty close. That looks very close to perpendicular. Right there, perpendicular. That's a right angle. So 1/3 is perpendicular at -3. And so you might see a relationship between those numbers. If I put 1/4, maybe you can guess 1/4 what the answer is going to be. That's close. That's really close. That's perpendicular right there. That's a right angle. Okay, so 1/4 to -4. How about this? The only thing I wish Desmos showed fractions, but it doesn't. But I could say, let's change this to, what if I change this to -1/2? Okay, so now let's figure out what's perpendicular. So now I got to change it quite a bit, play with it. Oh, that's getting close. It's getting close, close, right there. So -1/2 gives me, if the red is -1/2, the blue line has to be at m equals 2 to be perpendicular. If I tried, how about -2? Let's see what this has to be. -2, so just adjust the blue. So hopefully you're just playing on your own a little bit. But right there is perpendicular. So when the slope is -2, the perpendicular slope is 0.5, which is 1/2. And that's what I want you to get. If I did -3, let's see what it should be. Oh, it won't be perfect on here, but it'll be close The closest one would be 0.3. But that's not quite perfect because it should be 0.33333, which is 1 over 3. So this is what I mean by negative reciprocals. So in this case, let's draw it out on the graph then. Here I have a slope of 1 over 2. If I want to draw in a perpendicular slope, I'm going to do, I'm going to do a slope of negative 2 over 1. That would give me a perpendicular slope right there. Which is not quite right there. It's close though. Down 2 over 1. That would be my perpendicular slope. And what that is, if this is up 1 over 2, this one's down 2 over 1. And that's the negative reciprocal. And I'll explain that in words in the next slide. So a negative reciprocal is you take a fraction, you flip it on its head, flip it over, and change the sign. So a positive becomes a negative, and negative becomes a positive. Positive becomes negative, negative becomes positive. Okay? So you pause that to write it down. I'm going to move on. So if I want to state negative reciprocals of these slopes, so for part A here, I've got a slope of 2. I'm going to write that as 2 over 1. Okay, because remember 2 is the same as 2 over 1. Then if I wanted a perpendicular slope, which is the negative reciprocal, you flip it and you change the sign. So it becomes 1 over 2 and it becomes negative. Okay, so that's how you find the slope of a line that's perpendicular. You take the original slope, make it a fraction, flip it, and change the sign. In this one then, negative 1, that's negative 1 over 2. So negative 1 over 2, you flip it and you change the sign. It was negative, now it's positive, now it's 2 over 1, which is just 2. Okay, and the third one, when I have a slope of 1, that one looks weird, but remember 1 is just 1 over 1, so you make it a fraction, then you flip it, and you change the sign. 1 over 1 is just 1 over 1 anyway, but so those are the steps to finding. So if I had a line that had a slope of 2, and I asked you to tell me a line that's perpendicular, you'd say it would have a slope of negative 1 over 2. That's using what we call negative reciprocals. Okay, so this question would be the application of that. Give the equation of a line that is parallel and an equation of a line that's perpendicular to. Now, when I type them in, it always looks like that, minus 3 over 2, but that actually means this. That's why I wrote that again, okay? This here is just me trying to say this, okay? So a parallel line to that. So this is my original. So I need to find a line that's parallel. Well, it has to have the same slope, but it could have any y-intercept I want, right? Same slope, different y-intercept would be a parallel line. If it had the same y-intercept, then it'd be the same line. So if you're looking for a line parallel, so I could have written 143, I could have written 2, I could have wrote minus 7. And just to remind you of that, I'm going to jump to Desmos here. Pause if you need to. What was that question again? Minus 3 over 2. So say I wrote in y equals minus 3 divide by 2 x, what was it? Was it plus 1? Okay, and I want to find a line that's parallel. I would just do y equals minus 3 divide by 2. I said plus 147. That won't fit on my screen. I'm going to say plus 7. Oh, whoops, I didn't put an x in there. See how it went horizontal on me? There we go. Parallel. Okay? Notice, by the way, that 3 over 2x is the same as 3x over 2. Not that it matters very much, but that is true. They're the same thing. Okay? So that's how you find. Now, perpendicular, you have to use the negative reciprocal. So you write out the original, right? And so what do? You take the slope to get the perpendicular, you flip it, and you change the sign. So it's 3 over 2, it becomes 2 over 3, and it becomes positive because it was negative. And now you have a line perpendicular. So I chose these huge numbers just to be, sort of make the point that it could be anything. But just for the Desmo screen, let's choose something smaller. So here's my original right there. Now I want a perpendicular, so I'm going to say that's got to be 2 over 3. So let's just say plus 2 or something. Right, so that looks perpendicular. Okay, so you flip it and you change the sign, and then the y-intercept, this could be anything. It could be 11, doesn't matter. Again, if I do 147, you're not going to see it. Can't see it on my screen, but anyway, I can make it a direct variation if I wanted to. Okay, so that's finding, and that's a very typical question. The way that I can make this harder is doing standard form. So in this question, give the equation of a line that is parallel and equation of a line that is perpendicular to that, which is standard form. So the first thing, other than the fact it really is the same question I just gave you, but you have to rearrange it. So it involves 2 major steps. Going from this form to y equals mx plus b form is the first step, and then just choosing what the m's should be. Okay, so this first bit you can see I'm just going to be rearranging. So I'm trying to get y by itself. So because it's a negative y here, I'll add 3y to both sides. So now y is over by itself here. I just flipped it here, so I have the y on the left. And then you divide each term by 3. And that's going to cause, I know I'm going fast, I'm hoping you pause if you need to. That's going to allow me to cross those out and end up with my equation, y equals 2 over 3x plus 1/3. Remember, the b doesn't matter in this question, because I just got to name some other line that's parallel to that. So this part's the part you should have from a couple days ago, be pretty good at. And then getting it into standard form, or sorry, not from standard form to y equals mx plus b form. And then to get a parallel line, I just chose 54, but it could be anything, but it's going to have the same m, right? And then perpendicular, it's going to have any b I want, but it has to take that slope and just flip it and change the sign, negative reciprocal. Okay, so that's finding equations of lines. That's one of the harder questions. Now here comes the grand poobah though. So the last example of the day is the grand poobah question. Aptly named. I think this one is really hard. There's one that's harder, the mother. I have it over here. It's the mother of all questions, but we're not doing that one right now. Here comes the grand poobah. This is the last question we're going to do today. So find a line that's perpendicular to this and has the same y-intercept as that. So it's kind of like, I should have done this before. I don't want you to get focused on too much on this side, okay? I want you to focus just on the left side for now. Okay? So over on what this means is I need some new line, and it's going to have an m that's the same as this m, and a b that's the same as this b. So these are the two, here's this 2x plus y, that's this one here, and the y-intercept part's right here. And remember, there's different ways. Finding the m, you could put it into Desmos and find it from Desmos, or you could rearrange it by getting y by itself. Either one of those things would work, and maybe I'll do it both ways. So just looking at the m part then, so I don't think, it's not that this math is so hard, it's just that it's a weird question, right? You got 2 equations, and you have to pull the b from this and the m from that, and it's perpendicular too, by the way. It's not going to be the same slope, but anyway, so let's just go ahead, rearranging this one. You need to get y by itself, so I'm going to subtract 2x from each side first, right, to end up with y minus 8 equals minus 2x, and then add 8 to each side to get y by itself. Okay, that's just basic rearranging. And I need this slope, and it's -2. Okay? So again, what I've done here is just typical rearranging to get y by itself. And then there's my equation. And so I need, just to be clear, I'm going to jump up here. I need a line that's perpendicular to that. So I'm not going to use this m. I'm not going to use -2. I'm going to use the negative reciprocal. Okay? So you rearrange the equation, you get m by itself, or not m by itself, y by itself, figure out m, and find the negative reciprocal. Okay, so it was negative 2 over 1, now it's 1 over 2, positive 1 over 2. The other side is the same idea, but now we're looking for the y-intercept because it says we need the y-intercept from here. Okay, so yep, you can use, actually it's really easy to use Desmos for this one. If I just take 4x minus y plus 3 equals 0, put that in, 4x minus y plus 3 equals 0, there's a line, get rid of that, and it crosses at 3. So there's my b. That's all I need to know. I need the same b as this line, which is going to be 3. But I could rearrange it, get y by itself, and there it is. So now my new line, my answer isn't the two pieces of information. The answer is the new equation that has this slope and that y-intercept. So it's not that I don't think the question's that hard. The math isn't that hard, but it's just really understanding like what is the point of this question. Of course, you could easily ask what's the point of that question. I wouldn't have a good answer for you, but that's what it's looking for. Okay, and I'll show you the grand poobah. This was the grand poobah. The mother of questions is, we'll do that another day, but here it is. It's finding an equation that's perpendicular to that and has the same not y-intercept but x-intercept as that. And it's hard. It's a hard question. But if you can do that, you're set for grade 10 math, that's for sure. There's nothing they'll show you in grade 10 math that'll be too hard if you can figure that out. Anyway, we'll worry about that later. So that's the last thing for today. Try the homework questions. Hopefully you have some luck with it. Yeah, good. Good. I hope you were good for your teacher. And I'm going to ask your teacher to give me a report. And I don't want to have to ask anyone for detention. So make sure you get some homework done and do your exit card. And I'll see you on Tuesday.